So MongoDB provides an in-house solution. I will be using MongoDB Compass. Next, we want to find different groups of status in which orders are present. So for that I can use but while writing in code, you actually need to, it should not exceed 16 megabytes. If it exceeds 16 megabytes, data is stored in MongoDB in a document-based structure. There are situations where we want data processing to happen. This data processing can involve data manipulation, filtering of data, grouping of data based on certain conditions. We can have arrays, we want to sort certain data. So MongoDB provides an in-house solution to perform these operations, and that is known as aggregation pipelines. The way aggregation pipeline works is MongoDB has something called stages. The concept is you perform some aggregation in stage 1 and then you get some output of this stage 1, and then this output 1 is passed to another stage where we would have certain query written and we will get some output 2. So this way we can perform all the data processing techniques to achieve our final result. That is what aggregation pipelines is all about. We call it pipeline because data is flowing through different stages. It will be more clear with the help of example. So let's start. For the purpose of this video, I will be using MongoDB Compass. It is a free application. You can download it in your system. It is used to view data stored in MongoDB. Downloading this is simple. You can type MongoDB Compass in Google and then you need to click on the first link of the search result. It will say something like www.mongodb.com. You open the website and download it, and then you will find a user interface similar to this one. For the purpose of this video, I have created a database called e-commerce and I have created two collections called customers and orders. The data present in both of these have actually been generated using ChatGPT. Talking about each of these collections, the customers collection has customer ID, name, email, phone and the address, and the orders table has order ID, customer ID, order date, status, total amount, shipping address which is a map object, and then items which is an array of objects. We will perform all the aggregation operations on these two collections. So let's begin. The MongoDB aggregations happen under this aggregations tab. Let's understand this with the help of problem statements. So my first problem statement is I need to find all orders that are shipped. For that we can go to our orders table. We can see it has a status field and it has some value shipped or delivered, and I need to find all orders that are shipped. In this orders collection there is a tab called aggregations. I will go there where I can write my aggregations query. As I mentioned, we have something called stages. My first stage is to find all documents that have status as shipped. I will use an operator which is called match. So it is similar to where clause in SQL. By the way, this drop down gives me all operators which this aggregations pipeline support. There are lots of operators and we will cover most of the frequently used operator in this video. I will use the match operator, and here I need to write a simple query to find all the documents with status as shipped. So I have the status field and I need to filter where all the documents value is shipped. You can see I get a list of documents. I get 2 documents where status is shipped. Now this output acts as an input for the next stage. So let's assume I want to find the number of orders that are shipped. So to find the number of orders that are shipped, I will first need to find all the documents that are shipped. So my match operator gives me that result. Next I will add a stage to count the number of documents. So this document goes as input to my next stage where I will use the count operator, and here I need to provide a name for the field. So I will write count shipped and we get output as count shipped as 2. The output of these 2 stages, the final output is count shipped. Here we are getting a nice UI to write each of the stages, but while writing in code we actually need to export this pipeline we can select which language we want our code to be written as. So if I select Java, I will get a Java syntax. For now I will keep the video language agnostic, so I will continue using this GUI. The main motive is that you understand the concept behind aggregation pipeline. So let's see further questions. Next, we want to find different groups of status in which orders are present. So for that I can use the group operator. So first I will add a stage and I will select the operator as group. For now I will remove this expression, I will come back to it later. But now I need to group by status because I need to find different statuses in which orders are present. So for that I will name an ID and $status. So it will give me all the different statuses. It is similar to group by clause in SQL if you are aware of it. We have some documents with delivered, with shipped and with pending as their status. So hence I get these documents. Now each document only has ID for now. Now let's say we want to count the number of orders in each status. In that case we will use something called accumulators. So we will add a field, we will write something like order count. Now these are custom defined field. It has nothing to do with MongoDB syntax. So after this we will write our accumulator function. We want the count of each order for a particular status. So I will use a sum operator for that. I can write $sum and I want to increment the sum by 1 whenever we encounter a document. This will give me the order count. We have 2 orders which are in shipped status. Now since we are grouping by status, that will be a unique identifier for our document, and we can have order count mentioned as 2. Now we can also change this to status count and my resultant document will change. So this is how we use group operator and accumulator operator on top of it to create document on our own. This document isn't present in any collection, but we actually calculated it in runtime. The ID field in group operator also supports null value. Null simply means it will go through all the documents, like it is aggregation of all the documents present in the collection. So for example here, if I add the count orders key, if I add this and if I sum over it, it will give me a count of all the documents present in the collection. So it gives me 5, which means it has taken into account all the documents present inside the collection. So this is with the group operator and null combination. Now let's assume we want to find the total sales across all orders. So my orders collection has something called total amount. I need to find the total sum across all documents. For that I will use null in my group by clause and I can rename this key to total sales, and instead of incrementing by 1, I will actually increment it by this key, by the key called total amount. So the way this works is, we go to one document, it sees the total amount, it adds it to the total sales value, and this way it aggregates it over all the different documents present in the collection. So here sum was an operator. Similarly, if we want to find the average order value across all the orders, we can change the sum to find the average, and I can rename this to average sales, and this will give me the average sales for all the orders in the collection. Now let's say we have a use case where we want to find the total quantity for each product sold. So if we look at the orders table, I have items and each item has a product ID. So we want to find the count against each product. So this is going to be slightly tricky because we have the orders table and each product is within an items array. So whenever you want to apply aggregation on some array, one operator should come to your mind. It is called the unwind operator. I will just delete this and I will write unwind. So the use of unwind operator is it will flatten out the array. So for example, if this array has 2 elements, the unwind operator will create 2 documents with all the fields as same except the items array. This will have one document and the second will have another document. For example, let's say we have an key1 has some value and we have an array of 1 and 2. Unwind will create me two objects. One object will look something like this. The second object will be exactly same, except that the value of the array will be another element. So this increases the space occupied, but it is easy to operate on flattened form of array. Whenever dealing with arrays, make sure to use unwind. Don't make sure, but unwind should be a thought in your mind while operating on such cases. So now I want to find the total quantity of each product sold. So I will use the unwind operator and I will unwind my items. So I will just write here items. So I need to write here path. In path I need to specify items because I want to unwind my items. So the resultant object, you can see my items is now an object instead of an array, and it has unwinded the array. So now that I have got my items separately, I need to find the total quantity of each product sold. So I want to group by the item, the product ID. So I will use the group clause, and now if you look, it is like a nested object. So group also supports grouping by nested values. So here I will group by items dot product ID, and I will have a $sign here. Now you can see I have got different documents grouped by the product ID, and I wanted to find the quantity of each product sold. Now after the first stage, when I got a result, it also has something called quantity. So my accumulator here will sum these quantities. I will write here quantities sold, and then I will perform sum. I will perform the sum on the quantity of each item. So this will give me the result where I get the quantity sold for each product ID. So I get a sample of 8 documents. This is about how to use unwind and group together. Next, let's assume I want to sort my orders based on the order date. For that I will use an operator called sort operator. I will delete, and so each order object has an order date. To sort it, I will simply select the sort operator and I will use the field order date it suggests me. And since we want to sort in descending order, we will just pass -1. If we wanted to sort it in ascending order, I would have passed 1. So yeah, as you can see, the order date for this is 25th August, order date for this is 20 August, and order date for subsequent documents are decreasing. So I was able to successfully sort it in descending order. So that's with the sort operator. Next, let's assume I wanted to find the 5 most recent orders. In that case, I will first sort the orders in descending order, which I already did, and then I have something called limit operator. So I will pass the result of the first stage into my second stage, and in the second stage I will use something called limit, and I will simply provide the number of documents I need. So it will cut off the document starting from the first count. So if I mention here 3, I will get the first 3 documents, but I wanted 5 most recent orders. So I will provide 5 here and I get 5 different orders. So that's about the limit operator. Now let's assume my next problem statement is I need to count the number of orders from each city. In that case, I will first look at my document. I will see that it does not have any city here, but I have something called shipping address. Now shipping address has city, so this means I will first need to group my documents based on city. After that I have to count the number of documents belonging to that city. So to do that, I will add my first stage in which I will use the group operator, and I will group based on city. So my base key is shipping address, so I will mention shipping address here, and then inside shipping address I have city, so I will write shipping address dot city, and I get my output as different city names. And now I need to use the accumulators function. I will name it number of orders, and I want to perform a sum operation on each of them, and whenever I encounter a document I will increment the sum by 1. So now I get my final document. I see there is one order from Seattle, one order from LA, one order from Chicago, one from San Francisco, and one from New York. So that looks fine. This is regarding number of orders from each city. The next problem statement is interesting. I need to find orders that include a specific order. So for example, this order has a particular item, product ID 001. So how do I find documents that have prod 001? In that case also I can use the match operator. The match operator is pretty powerful. It can match within arrays, it can match within objects, keys. So I will use the match operator for this. Delete, and I will select my match operator. So I need to check items.prod id, items.product id at auto suggested should be equal to prod 001, and I see there is only one order that has this particular order, so that is my answer. Now my next problem statement is, how do you find orders with exactly 3 items? We need to find documents and filter based on the size of an array. Well, we can use the size operator for that. So I will still use a match operator, and inside the match operator I will use the size operator. So I want all documents where size is equal to 3. Now the size I am talking about is actually the size of the items array. So I don't have any document where the item size is 3. Let's try 2. So yeah, I get documents where item size is 2. So I will actually change this to find orders with exactly 2 items. So this will give me my desired result. Next, let's say my problem statement is find shipped orders from New York. So in this I need to have match on multiple parameters. So I need to match that the document should have status as shipped, and the document's address should also belong to New York. So for that, like this is having match on multiple parameters, so I will use match again, and my status I will set as shipped, and I get a sample of 2 documents, but I also want shipping address dot city should be equal to New York. So it seems there are no documents. I will change my problem statement little. I will say status pending, just to show that the query is working. I changed the problem statement. So I get one document where both status is pending and shipping address city is New York. This way you can pass multiple conditions within the match operator. You can also use regex within match operator. For example, you wanted, let's say, all the cities where the city name starts with the letter N. In that case you can actually use regex. For that I can pass regex as operator in this $regex, and then write a simple regex N. So I get one object where the shipping address will be New York. So this is how you use regex within match operator. I will just log the problem statement where city starts with N. My next problem statement is, I want to return only certain fields in the order. I want to return order ID, customer ID, and total amount. In that case I can use something called the project operator. So my orders collection has order ID, so if I just pass here order ID, so it like included order ID in the document. I can choose to show customer ID, and it will add customer ID also in the document, and I can have total amount, so it will show the total amount as well. The integer after each of this key is just part of the syntax. You don't need to worry about it. So this way you can selectively show fields in the output. And for example, if you have a very big document and you don't want to expose all the fields in the output, or you want to control the size of your response from database, you can use this project operator. Now coming to our next problem statement, let's say we have to filter, we have to group by status and For each status we want to see what are the order IDs for those status. So return order IDs for status. So looking at the problem statement, it is clear it will have multiple stages. First I need to group by status, so I will just group by status. It is actually dollar. So I have shipped, delivered and pending. Now I also want to show order IDs in this. So my order IDs will actually be an array, so I need to create array for each of these documents. The way to do that is to use the push operator. So I will create a field orders. This is the field name that I give orders, and then my accumulator function will be called push, and I need to push the order ID. So it will create an orders array where I will have order ID for each status. If you had to do this in your application code, you would have to write quite a bit of code, but using MongoDB Aggregation Pipeline, it is very simple. Coming back to my next problem statement. So I need to find the orders containing both product 1 and product 2. So my orders collection has an array of items. Now I want to filter on the array of items. Like we had done this before, but we had done it for filtering one product, but now we need to do it for multiple products within the array. So for that I will use something called the all operator. I will use match as my base operator, and inside this I want to check the items field, items.product ID field, and in this I will use the all operator, and it should check on prod01 and prod02, and seems like no documents have both the combinations. So I will take these two values, prod003 and 004. So yeah, I get one document where both of these are present, and this array is like a subset of all the items array. So this items array could have been very big, but if the items array contained both of these values, it would have still shown up. Now let's move to a more interesting problem statement. Let's say I wanted to fetch values from a different collection. So for example, I have two collections here, orders collection and customers collection. Now the orders collection has my customer ID, and if I wanted to fetch the customer details along with order details, I can use something called lookup in aggregations. Add customer details in the orders. Add customer details in the orders. For this, in my orders aggregation, I will use something called lookup. It's the lookup operator. This has four fields: from, local field, foreign field and as. So the from is from which table I am looking from. So currently my orders table wants to look from the customers table, so I will mention customers here. And local field is the field name present in the orders table, in the current table. So in the orders table we have something called customer ID, so I will mention that here. And foreign field is the field in the customers table, so I want to match it with customers table. It also has something called customer ID, so I will mention customer ID and foreign field. And as, like, what do I want to call it? I want to call it customer details. So I get my result as this. So I get the customer details included inside each order as an array of objects. So for customer 1 I get something like this. Now why did it create an array? It is because of the way data is stored in MongoDB. So for example, if there were multiple documents with the same customer ID, it would have appended the other customer object also within this. From an application point of view, there should be only one document, but since there is no restriction in place, that's why MongoDB decided to create an array in place of a single object. Now if we don't want this as an object, we can always choose to add another stage to it, and we can use the project operator, and we can specify the fields that we want. For example, we may want order ID. So the input to the second stage is actually the output of the first stage. So I can take order ID, I can take maybe status, and I can take customer details. but let's say I don't want this as an array, I want it as an object. In that case, I can pick up the first element of the array. The way to do that is we will use the arrayElemAt operator, and we will actually name this customer, and this will take the first element of customer details. I can like name it just customer, and arrayElemAt will fetch the element at the 0th location of this key. So this key only had one element which was at the 0th location, so it fetched that as an object, and now I have a proper object rather than an array. The other way to do that would be use the first operator. So the first operator will take the first element of the array mentioned here, and this also gives me the same result. So the way to convert array to object is use either first operator or arrayElemAt operator. So this is about lookup, where you can do joins between two MongoDB tables. So yeah, that's about the basic of MongoDB operators. Now let's look at slightly more complicated and advanced problem statements. For example, if I had to find the top 5 customers who spent the most money on orders, to solve this, my first step is clear. I need to group my orders based on customer ID. So let's do that. I will delete and I will add a group by operator. I will remove this accumulation for now just to keep things simple. I will group by customer ID, this is $customer ID, and I got 5 documents. I want to find, I will actually change this to top 3 customers, and then I want to find who have spent the most money. For that I need to calculate how much each of the customers have spent. I will accumulate, I will write expenditure. This is a custom name, so I will name it expenditure. I want to sum based on total amount spent, so I will sum based on total amount. So now my resultant document is grouped by customer ID, and the expenditure for each of the orders is added up to get expenditure. Now my problem statement requires me to find top 3 customers. So this means I need to sort this output based on the expenditure. So I will use the sort operator, and I need to sort on expenditure. Now if you see, expenditure is a field that is not present in the original collection, but we got this document as output of stage 1. The second stage is taking this expenditure as input, and I want to sort it in descending order. So I will write -1, and I see that customer 4 spent the most, and we see a gradual decline in the expenditure in the order in which we get the response. So but we want only the top 3 customers, so I will add a new stage to this, and I will use the limit operator, and I want to limit to just 3 documents. So I will mention 3, and my output size is a sample of 3 documents where I get my top 3 customers. And here I had to write 3 different queries, but you can always export this code, and this is the MongoDB way of writing this pipeline. It is an array where you have 3 objects. First you use the group operator, then I use the sort operator, and then the limit operator. If I am using Node.js, I can directly copy this to my code and use it. I can also select to include the driver syntax, where it will give me the MongoDB code to connect and everything. So it is pretty helpful in that way, but for now I will stick to this particular screen. So this is how I found the top 3 customers who spent the most money. My next question is, find all orders where a customer is from a specific state and the order status is delivered. To solve this, we need to make a join between 2 tables. So the customers table has the state and the orders table has the order status. Now since we have to use joins between 2 tables, we need to use lookup. For that I will add a stage where I want to do a lookup. I want to do a lookup from the customers table. The local field will be customer ID and the foreign field will also be customer ID, and I will call it customer details. Now I have got customer details in one object. My next target is to filter based on specific state and order status. Since customer details is an array, I can also use unwind on this array to get customer details as a separate object. So I will use unwind for it. I will just remove these values $. So now I have got customer details as an object where I have their exact address, where I have the state information. My problem statement said find all orders where customer is from specific state and order status is delivered. Now I simply need to use the match operator to filter based on these records. So I will add another stage, and in this I will use the match operator and status should be delivered, and my customer details dot address dot state, it's a double nested object, should be equal to CA. I will put this in double quotes, and yeah, I got my result. I can see that this customer is in CA. So this required 3 stages to solve. For the last question, I want to show customers and their summary, but I only want to select customers who have placed orders more than once, which is they should have placed at least 2 orders, and I want to show the total amount spent by such customers and an array containing their order IDs. So let's see how to solve this. To solve this question, I want to group my orders based on customers. So let me do that. I will add a staging where I want to put group by. For now I will remove this accumulator. I just want to check that group by is working correctly. So I will group by my customer ID, and I get 3 documents, customer 3, customer 2 and customer 4. Now I want to show the total amount spent by these customers. So I will create a key total amount where I will sum on the amount spent by each customer. So I have the total amount key, so I will sum on total amount, and in my output I get the total amount. I also want an array of order IDs. For that I need to use the push operator. So I will create a key called order IDs. I will use the push operator, and I want to push order ID. So this created order IDs for each customer. Now I also want to show only customers who have placed more than one order, who have placed 2 orders or more. So I will have another field called order count. To count the number of orders, I will use the sum operator, and we want to increase the sum by 1 whenever we encounter any document. So customer 3 has 1 order. The order IDs also has 1 element. Similarly, customer 4 has order count of 2 and customer 2 has order count of 2. To find out documents where order count is greater than or equal to 2, I will create another stage where this stage takes this output as an input, and I will use the match operator, and I will match on order count, and this order count should be greater than 1. So here I filtered all the documents where order count is more than 1. So I wanted this data, but in the problem statement I just want to see the summary. I just want to see the total amount spent and an array of order IDs. I don't want to see the order count. For that I will create another stage. In this stage I will use the project operator. In this I will mention customer ID, which is basically the ID in the input. I will show the total amount as it is, and I will show the order IDs as it is. It doesn't show anything because there's a syntax error here. Yeah, this is my output, and this is what I wanted, to show the summary of all customers where order count is more than or equal to 2. So this is about MongoDB aggregation pipelines. I went through different problem statements to show you how each of the operators works. To sum it up, we looked at different operators. We looked at the group operator and how it can be used to group documents based on certain criteria. Then we saw how to use accumulator functions on these groups to aggregate data group wise. We also looked at the match operators where you can filter data based on certain conditions. We looked at count operator which counts the number of documents. We also looked at the project operator to modify our output in a certain way if we want selective fields to be shown as output. We also looked at the lookup operator which can be used if we want to join between two tables. We looked at how we can unwind arrays using the unwind operator. These are the basic operators which you will use frequently in your project. So that's all about aggregation pipelines. There's one more small thing I wanted to discuss. It is regarding the limitations in aggregation pipeline. As per the official documentation of MongoDB, each document in the result of the aggregation pipeline should not exceed 16 megabytes. If it exceeds 16 megabytes, your pipeline will throw an error. In case the pipeline requires more than 100 MB to process the data, you can use something called allow disk use by default and set it to true. So if any of your pipeline stage requires more than 100 MB to process, MongoDB will use your disk rather than RAM to process the data. To know more about these restrictions and how you can mitigate these responses, you can refer to this official documentation of MongoDB. Now, the number of operators I discussed today were very limited, but MongoDB offers a wide range of operators that you can use. You can check out these in MongoDB's official documentation. So that's it for this video. Hope you enjoyed this video and learned something new. Make sure to hit that like button and don't forget to subscribe to my channel Code with GD. See you next time. Till then, happy coding. Bye bye.